expanding with the distributive law. In this video, I'm going to go through sort of an algebraic form of the types of expansions that we'll have to deal with, and then a bunch of different examples. If you find that you want to skip through some of the examples, that's no worries if it's taking too long, because I just want to make sure that any example you might want was there. So a reminder that the distributive law says that if we are multiplying a sum or a difference by a term, then the multiplication is distributed across both terms of that sum or difference. What I mean by that is that if we looked at this as with some numbers instead of letters, if I've got 3 times the sum of 6 and 4, I can do the sum in the bracket first. That would be 6 plus 4 is 10. 10 times 3 is 30. That is not using the distributive law. That is using order of operations, which says do the sum in the bracket first. The distributive law is an alternative to the order of operations, where I say I will distribute the multiplication by 3 across the 6 and the 4. So I will do 3 times 6 plus 3 times 4, that's 18 plus 12, that's 30. The reason that we might want to do that is sometimes it can be easier to do a multiplication by 2 terms and add, instead of adding first and doing the multiplication. And when we have algebra involved, often we use the distributive law to simplify an expression so that we can manipulate it further. So the distributive law distributes a multiplication across the sum or difference. Now, we just need to make sure we know that A outside of B plus C is equal to A times B plus A times C. A outside of B minus C is equal to A times B minus A times C. Now really what we're doing, remember, is we're multiplying each term. So this is A times negative C gives us negative AC, which in the scheme of things is AB minus AC. When we are multiplying what's known as binomials, that is brackets with 2 terms in each multiplied together, you have 2 different options for how you would expand this, and I'll go through them both. But this is A times C plus A times D plus B times C plus B times D. 3 different particular types of binomials, one of which I didn't write the example for, so I'm sorry about that. I will put in that right now with this pen that matches. Sorry about that. Perfect squares are when it is one set of brackets squared. This is equal to A plus B times A plus B, which is, of course, A times A, which is A squared, plus A times B plus B times A, which is 2AB, plus B times B, which is B squared. If you weren't quite sure how I did the perfect squares to get this, I will go through the perfect squares again later. In the same way, this is A minus B times A minus B, which is A squared minus 2AB plus B squared, because negative B times negative B gives us positive B squared. The difference of perfect squares is when the terms in the brackets are the same, but we have different signs, so plus and minus. If we multiply this out, that's A times A, it's A squared, plus Alright, so we've got a times negative b, so that's minus ab. B times a plus ab. Positive b times negative b is minus b squared. Look at these, they cancel out. A squared minus b squared. So the difference of perfect squares and the two perfect squares are examples of binomials that you're going to need to recognize. So I've just got a whole bunch of examples. Expand and simplify where possible. Negative 3 times x is negative 3x. Negative 3 times negative 5 is plus 15. If you preferred, you can write this as two multiplications. Negative 3 times x minus 3 times negative 5, because it's minus here rather than plus because it's a negative 3 there. Negative 3x, negative 3 times negative 5 plus 15. It will get you the same answer. Some people prefer to write the multiplication. Some people prefer to just do each multiplication. Do not lose track of your negatives. A negative times a negative is a positive. And do not fall into the trap of doing the first multiplication and then writing minus 5 and forgetting that you have to do both multiplications. 2/7 outside of 14x plus 3. You've got a couple of different options as to how you approach this depending on how comfortable you are with fractions. You may find that it's easier not to get too cocky and do too much in your head, but to write out the multiplication. This is 2/7 times 14x plus 2/7 times 3. Sorry, that's a little bit of a light colour. So you can cancel out your 7s here. So I've got 2 times 2x is 4x and plus 6/7. So just be a little bit careful if you've got fractions involved. Here is an example of one that is very likely to trip you up, and that's when it's two sets of brackets to be expanded and then simplified, and I've very deliberately put a negative second term. X times 2x is 2x squared. X times negative 1 is minus x. Now this is negative x times 3 minus 3x. Negative x times negative x plus x squared. This minus here is distributed across that multiplication of the whole two terms in the brackets, and you are very likely to get this as a negative, minus 3x, and then think that you're just doing x times negative x and forget that this negative belongs to that x. Do not make that error. It's a very definite dead fairy error for those of us who know what dead fairy errors are. Don't do it. Negative x times negative x is plus x squared. Then you can gather your like terms. 2x squared plus x squared is 3x squared. Negative x minus 3x is minus 4x. So gather your like terms. If you need to revise what like terms are, there would be a revision video available. Same pronumeral and same pronumeral power. Here is a binomial expansion. You can use your old friend FOIL. Where will I write FOIL? No space. FOIL just says first, outside, inside, last. That says you multiply the first two, you multiply the outside ones, you multiply the inside ones, you multiply the last ones. Some people prefer to think of it in terms of a little lobster claw drawing lines, which is exactly the same as FOIL actually. I'm multiplying these two. X times x is x squared. X times 4 plus 4x. 5 times x plus 5x. 5 times 4 plus 20. Gather like terms, x squared plus 9x plus 20. If you preferred, you can also write this as something more similar to that. And I'll just pop in some extra paper here. This is the first term in the first bracket times the second bracket, x outside of x plus 4. Then the second term, including its sign, plus 5, and that gets multiplied by the second bracket. So if you prefer to do a binomial expansion like this, x times x is x squared, x times 4 is plus 4x, x times 5 plus 5x, and x times 4 is 20, x squared plus 9x plus 20, then you absolutely can. Some people definitely prefer this. Some people prefer to just manage all the multiplications, and you can, of course, do it without drawing the little lobster claw. Here is a perfect square, because it's one bracket squared. If you are at all likely to mess this up, then I strongly recommend that when you see a perfect square, you write it as two separate brackets. This is another dead fairy error. Do not, under any circumstances, decide that x minus 4 squared is x squared minus 4 squared, or even x squared plus 16 or anything. Absolutely not correct. It is not this term squared minus this term squared. It is this bracket times itself, which happens to look like this. By always writing a perfect square as two separate brackets multiplied together, you will avoid that dead fairy error, because the result of this is x squared. X times negative 4 is minus 4x, so that's, I've done those two. Negative 4 times x is minus 4x. Negative 4 times negative 4 plus 16. Notice that when you are expanding a perfect square, your two middle terms are always the same. And so when we gather like terms, that is x squared minus 8x plus 16. If you are very comfortable with this, you are most welcome to go straight from this question to this, because you know that a perfect square expanded will give you the square of the first term minus, plus or minus 2 times the product of the two terms and the second term squared. So when we wrote our little rules, that's what this means. The difference of perfect squares, a perfect square, first term squared, last term squared, 2 times the sum, two times the product of the two terms. If you are not comfortable with that, always write it as two brackets and expand it. That's fine. This is a difference of perfect squares. Same two terms, different signs. You can always deal with a difference of perfect squares by just expanding and simplifying. 2x times 2x is 4x squared. Don't forget to square those as well. 2x times negative 1 is minus 2x. 1 times 2x is plus 2x. 1 times negative 1 is minus 1 squared, which is 1. These two cancel out. 4x squared minus 1. If you are comfortable with the concept of a difference of perfect squares, then you will know that as soon as you see one, you can simply square the first term, square the second term, and it will be a negative. So there's shortcuts if you're comfortable enough to use them. If you're not, don't. This is getting to be a pretty long video. If you don't want these examples, you don't have to do them. It's more for if you get stuck or have no idea what I'm doing in the textbook. A number outside of two brackets. Deal with the brackets, the binomial expansion first. So what I'll get is 2 outside of x squared minus 2x minus 3x plus 6. That's 2 outside of x squared minus 5x plus 6, which is 2x squared minus 10x plus 12. So expand the brackets, then deal with the product of whatever the term is out the front. Find an expanded expression for the area of a shape. If they're asking you for anything to do with area, start with the area formula of the shape you're dealing with. Area is length times width. Length, x, width, x plus 3, and we have to do x times x plus 3, which is why we set it out like this. So that is x squared plus 3x, and this is centimeters, so it is in centimeters squared. Just an aside that this is quite a useful little thing. If I'm evaluating 6 times 52, the idea of the distributive law is to write that as 6 times a sum that will give you, or a difference, that will give you 52. In this case, 50 plus 2, and I'm choosing 50 and 2 because they're really easy to multiply by. 6 times 50 is 300, plus 6 times 2 is 12. The answer is 312. A very useful strategy, especially mentally.